We can go beyond the simple implementation of an API with its own registry system inside Minecraft. In this video, we will add lots of things on top of what we had and make our dispersion API a very rich API. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. Before we start coding, I need to mention that I had done my brainstorming and I had a lot of chat with Olama. However, I want to tell you a brief explanation of what's going on. Basically, dispersion is a very rich physical term. It can be related to different types of materials being carried by each other. For example, solutions, suspensions, emulsions, colloids, gels, foams, and many more things that we will take a look at them. Because of that, we can't just simply behave like we are dealing with a gas or a heat API. Those are simple. Here we need to think more in depth, and as you see, Olama is suggesting that we need to add different properties to the system, and we have two types of components, three types of interactions, and different types of dispersion. Long story short, the way we will implement this thing is that we are not gonna deal with the functionality at all. We are putting the bare minimum possible there in the API so that the users of the API can utilize it. For example, I will add viscosity inside the dispersion. However, I'm not going to handle it. I don't care if something has high viscosity or low viscosity. I don't care. I will add a property for stability. However, I don't care if a dispersion is stable or it's not stable, or what should happen if it's not stable. These are not my responsibilities. These are the responsibilities that fall upon the mod developers who are using my API. They can totally ignore one of these properties or every one of them, or if they want to, they can utilize each and every one of them if they need to. Moving on, Olama started suggesting a bare minimum structure for an API. However, at that point, I had my own structure, so I just let him do his job to see what does it give me. And as you see, he says that dispersion should be an interface. Well, guess what? We made it a record. Then he has this component class. We will take a look at this later. And then you see that he's suggesting that we should have dispersion types as enumeration, and then inside different implementations of dispersion, we will handle things like solution or suspension and things like that. And each one of them should simulate the interactions and visualize. Basically, simulating the interactions are the three suggestions that he gave us as dissolution or distribution or reaction. And visualization is just animation and 2D and 3D rendering. However, as we all know, this is not how Minecraft behaves. Minecraft has client-side code for animating or rendering, and then server-side code for, I don't know, maybe doing some reaction effects or anything else that you want. Also, I don't want my dispersion to be an interface and then I have tons of implementations simply because I didn't make it a record or a class. Basically, you had seen it so far. We made the dispersion a class, and because of that, we don't really need to extend it to have solutions or, I don't know, suspensions. All of them can sit together. So I ignored this part, and this is exactly why I said you should be aware how you use an AI, especially when it comes to coding. Taking his suggestions and looking at his use case example, I was like, oh gosh, this is not how we use it inside Minecraft. I did my implementation, and between the previous episode and this episode, I started chatting with Olama Quen 2.5 coder, 32 billion parameters. I gave him what I had and what I did code in front of the camera. Lots of code there. And I said that, using this, please think about the attributes, components, extensions you suggested and give me more robust solution. So he started thinking and said, okay, you know what? You made your dispersion a record. That makes my life easier. Let's add parameters there. And some things that I really liked was his suggestion to move the empty dispersion into the dispersion class and the register methods into here instead of having it on dispersion API API, because when we are coding against the library, we would type dispersion.register. However, before this, we had to type dispersion API.register, and I didn't like it. Also, dispersion.empty makes much more sense compared to dispersion API.empty. I liked this suggestion so much that even in the gas API, I went back and moved things from the API class into the record class containing the registration and some gas types like air that I had there. This suggestion was nice. Also, it gives me a very firm idea on how to progress forward. And then you see that under the dispersion variant, he starts adding some methods to get things back. And inside IMPL, he implements them to get things back there. After that, he says that, if you want to implement the interactions, here is how you can do it. Under the dispersion variant, add this simulate interaction method, and under IMPL, you just implement it. Then he goes forward and adds the visualization the same way. And finally, he goes with the API. And here you see that he's doing something bizarre. He forgets that he moved empty to the dispersion. That's okay. He forgets that he moved register there. That's okay. And he starts registering different things inside our system using an event. This is not how we do it, but this is a good example on how something can be registered. For example, we have water solution, and these are the parameters related to water solution, and the stability is 0.9. This gives me an idea that, hey, maybe 1 means 100% stable, 0.9 means 90% stability and 10% chance of, something happened to the solution. And then again, the use case example is junk. So I went forward and said, okay, I agree with most of your suggestions. However, if you want to add the component, dispersion type, solution, suspension, what about them? Also, I gave him an example of a slurry stack from Turtiworty. I had my own gas stack and fluid stack that I could use, but at the time I had it at hand. So I said, what about that? You totally ignored that one. He goes on and says, okay, this is the complete component class. This is the dispersion type, and he adds the dispersion type on top of the dispersion itself. Then, of course, he adds the dispersion type into the variant, and then the IMPL returns it. And here is something that I was confused about. When I look at variant and the variant IMPL, I don't see him utilize that component, because remember, this is not the component class he's creating. This is data component patch. So I ignored that part and I said maybe he will suggest something later. However, he continues with solution and suspension being extensions of the variant IMPL. Now, I don't like it. Basically, if I'm gonna add the type directly as a part of the dispersion, then why should I implement the simulate interaction and visualize differently per type? Yes, I can imagine that someone may want to have a dispersion that does something during the simulation of interaction, maybe a chemical reaction. However, that is a use case example on the mod developer side, not on my side. I don't need to provide a solution IMPL. I mean, a solution is not a variant, for God's sake. A solution is a type of dispersion. And what he's suggesting is that solution is extending variant. So it's type of a variant of a dispersion. Physically speaking, it's correct. Solution is a type, is a variant of dispersion. However, when we go to Minecraft modding, the meaning of variant there is different, It's a variation of a single type. For example, a variation of a solution, a variation of a suspension, things like that. So I don't like this suggestion. We will take a look at how we can do that. And finally, he again forgets that he should remove these things from the API. He continues the example with the API. Of course, now he is adding the type there. And finally, the junk use case, as you see, I cut it out. I hit the stop button. I didn't let him continue. Here I ask, correct me if I'm wrong. In your example usage, you have this code, and this is actually adding a component. But in your variant or variant IMPL, we don't have anything to add the component. He says, yes, you are right. Of course, I'm right. Then he goes on, and you see that he adds two methods to the variant class, and inside variant IMPL, he implements them. Okay, so far so good. Again, he goes for the solution and suspension, and again, I cut it out midway, and I say, you know what, this is all good, but you did get me wrong for slurry stack example. I have these examples, gas stack payload, or down below I have fluid stack payload. I give him both, and I say, please produce a dispersion stack payload, and here's the information I want. I want a dispersion variant, an amount for the dispersion, an amount for heat, a list of fluid stack payloads, a list of item stack, a list of gas stack payload. And I should have a codec and a stream codec. And he successfully writes the class, although it's not complete. I need to make it complete. And then he says that, okay, in your example, in your question, you mentioned dispersion storage. Please implement it. This is the boilerplate. Of course, I know how to implement it. And again, he goes on and adds an example. However, here you see that he is adding a dispersion stack with a solution variant, with amount, with heat, list of water fluid, list of item stacks, and list of gas. And finally, I say, okay, I'm done with your code examples. I know what I'm doing, and you were really helpful. However, I need to change your code. That's okay. Give me something. Are these the only type of dispersion? And he says, no, we have lots more. And he continues explaining for 10 different dispersion types. Of course, he's kind enough to add them to my dispersion type enum, and then he screws up. And I stop him. Okay, I don't want to look at your code. I just asked about a physical concept. So you see that AI sometimes give a very good, robust solution, in this case for the codec. However, this time he screws up on the codec, and he thinks that solution, suspension, emulsion, all of these are different classes with different codecs. And funny enough, he's adding all of them on top of this codec as a combined codec. I don't need that. That being said, 15 minutes later, we can start coding. However, I want to stop this video here, and immediately I will publish the next video, so you will have 2 videos in one day. However, I did want to keep this brainstorming video away from the coding video. This will be an example of how you can really utilize a good AI. And by the way, this is a local model. I downloaded it, put it inside a folder for Olama, and now I can use it even when I'm offline. He's doing decent job. Of course, there is Qwen3 coder, if I see it. Qwen3 coder 30 billion, but I didn't download it yet. Anyway, 2.5, 32 billion is really robust and good enough. I wonder what would be the case for 3, and I will take a look at that later. I will close this video. Don't go anywhere else. Just look at the list. There will be another video with the start of coding. Have fun, everyone. Bye.